Okay, so in this one, we're also in the presence of a telescoping series. With a telescoping series is when you have two different terms here that are being added or being subtracted. The point is, it's split into two different parts. And so when it's split in this way, what we do is we plug in values. This one, we don't even have to split it. Sometimes you have to force the split. For example, if you have something in a denominator, and then you could factor it, then you could do partial fraction decomposition. In this case, we're just going to start plugging in values. So with the series, we have our first term where we plug in n equals 1, then we have n equals 2, then we have n equals 3. So let's start to see what happens here. Let me give myself more room with this. And this is going to be our first term where we plug in n equals 1. Here we plug in n equals 2. Here we plug in n equals 3. So we would get e to the 1 minus e over 1 half e over 1 half minus e over 1 to the power of 1 over 3 e to the 1/3 minus e to the 1/4. And you can see that this pattern is going to continue. Like if you went on to the next one, you would get 1/4 on this side, on the positive side, and so on and so forth. So you'd have this cancel out continuously. So we have the negative version of this, so that cancels out with that. We have the negative version of this, that cancels out with that. You could obviously see that the next term here is going to be the positive version of this, so that's going to cancel out with this over here. And so we can tell already that the only thing that survives is this guy, which is just e, because it's e to the power of 1, and we plugged in 1 for n. And now we have to observe what's going to be the behavior near the end of the series. So near the end of the series, we're just having one term that we're really looking for, because we just had one term that survived here. There's just going to be one term that survives over there. And so the term that survives in this case, we have to plug in e to the 1 over n minus e to the 1 over n plus 1. And then what would be the previous term before this? The previous term would just be if we had plugged in n minus 1. So we have e to the 1 over n minus 1 minus e to the 1 over n minus 1 plus 1, because we're plugging in n minus 1 into the n. So that would give us 1 over n in that exponent. And so this cancels out with this. And we know to just expect one term here because we only had one term survive here. And so it's always really going to be the opposite one here. It's going to be the negative that doesn't cancel out in that case. Here it was our positive guy. So we know for a fact that this guy is going to cancel out with the one from the one over here, which is negative. We have a negative, and it's going to keep going. You know, the negative is going to cancel out with the positive from over here. That's just going to keep going. That's our only guy that survives. That means that our sum looks like this, where we have that 1 over n plus 1 in that exponent, 1 over n plus 1, and we had this guy survive, which was just e. And then what we do is we take the limit. We take the limit as n approaches infinity with these telescoping series. This is our final step, to take the limit after we have plugged in values, eliminated everything that could be eliminated. We take this is just a constant, so e remains. And this, we're taking something to an exponent, and we're plugging infinity in the denominator of that exponent. That means that if we plug in infinity here, the exponent goes to 0 because we're dividing 1 by infinity. And anything to the power of 0 goes to 1. So this would be minus 1. So this is our final answer, e minus 1.